So today we're going to start Chapter 5, Section 2, and we're going to talk about trigonometric functions. You should have done this last year in your geometry class. Your teacher might have taught you the acronym SOHCAHTOA, which stands for, the SO is for sine, which is opposite over hypotenuse. So it'll be sine of an angle. Ka would be for cosine, and that's the A is adjacent over hypotenuse, and then the TOA would be your tangent, and that would be opposite over adjacent. Now we're also going to see the reciprocals to these, as well as we're not going to memorize it as SOHCAHTOA. We're going to be given an ordered pair, and we're going to memorize it with the variables x, y, and r. And you're going to see that on the next slide. You can use SOHCAHTOA if you choose, but it's going to be a lot easier just to memorize it with the variables x, y, and r. So let's go ahead and take a look. So these are going to be the trig functions when you're given an ordered pair, and that ordered pair is going to be on the terminal side of the angle, and you're going to be able to create a triangle. So for example, let's say I told you that we have an ordered pair, and let's say our ordered pair P is going to be the ordered pair 3, 4. I'm going to go ahead and graph that ordered pair. And come over here to the side. 1, 2, 3, 1, 2, 3, 4. I'm going to graph that ordered pair. I'm going to create a ray that is going to connect that ordered pair from the origin. So I'm going to draw it out here. And then now what I'm going to do is turn this into a right triangle. Now, when you create the right triangle, you're always forming the triangle back to the x-axis. Do not draw a side of the triangle back to the y-axis. It's always going to be down to the x-axis, and then this is forming my right triangle. My angle that I'm trying to write the 6 trig functions for is going to be located here. This is going to be my angle measure, and I'm going to use the Greek letter theta. So if you think about it, when you did it in geometry, the side opposite to the angle would have been here. This would have been the hypotenuse, and then this would have been the side adjacent. But instead, what we're going to memorize is the side opposite is going to be the y value, the adjacent will be our x, and the hypotenuse is going to be the r. Now, to find the r value, once you're given an ordered pair, there's a formula you can follow, which is really, it's just the Pythagorean theorem, but the formula to find r is going to be x squared plus y squared, and it's under the square root. Because if you think about it, what we would have been doing here is this is a leg and a leg, so x squared plus y squared equals r squared. This is Pythagorean theorem, ABCs here. So instead, what we're going to do, what we're doing here is, remember, whenever we wanted to find c squared, what you had to do was square root, and then this is how we get the formula that we're going to use to find our value of r. And if you think about it, I showed you that silly video of the unit circle. The r value is going to be the radius. And when we start dealing with the unit circle, that r value is always going to be 1, because 1 unit or a unit is equal to 1. So once you're given the ordered pair, you're going to need to calculate the r value. Once you have the 3 values for x, in this case it's 3, y is 4, and if I go ahead and pull this into the formula, 3 squared plus 4 squared equals r. 3 squared is 9, 4 squared is 16, 25, square root it, and r equals 5. Our r value will always be positive. Now that I have the value for these 3 variables, you need to memorize the 6 trig functions. Sine of theta is defined as the y value over the r. It's reciprocal. All you do is flip the fraction, so the reciprocal to sine is cosecant, so it's r over y. Cosine is defined as x over r. Secant is r over x, the reciprocal. Tangent is y over x, and cotangent is x over y. Now, notice this exclusion here that x and y cannot equal 0, because if you have a 0 in the bottom of your fraction, it's undefined, and it would be no solution. So if I go ahead and use the ordered pair that I just gave you, and I put it into each one, so for sine of theta, I would take my y value, and I'm going to put 4 over 5. The reciprocal, just flip it, 5 over 4. For cosine, the x value was 3. The r value we calculated to be 5. Reciprocal, flip it. Then for tangent, y over x, 4 over 3, and then 3 over 4. So once you take the ordered pair, or you're given the ordered pair, you're going to find the r value, and then from there, plug it in to the 6 trig functions that you memorize. Find a way to remember them. Before, what I used to teach is I thought of this alphabetically, and I thought, well, the letter C comes before S, so I would put that with the X because it comes before Y. But then I had a student one year that said, you know what? Because we're in a Catholic school, I don't think of the word sign as sign. I think of it as the word sin. And he thought of, why should you sin? It's wrong. So the sine gets the Y, and then the cosine gets the X. Whatever tricks are going to help you. So he always remembered, why should I sin? So y over r. Cosine is x over r, and then just know you flip it for the other ones. Also pay attention that some students get confused and think the two s's go together as reciprocals, but it's the sine with the cosecant, and then the cosine with the secant. So in an s and a c together, and then just tangent and cotangent. So let's also now talk about the coordinate plane and the ordered pairs and the signs that are on them. So down here, this is referring to each one of the different quadrants, 1, 2, 3, and 4. So here is my quadrant. Remember 1, 2, 3, and 4. This is the x-axis. This is my y-axis. Now, if you think about it when you graph an ordered pair, the signs of the ordered pairs in quadrant 1 are going to be positive, positive. The signs in quadrant 2, the x value is negative, and the y value is positive. If you think about the problem I just did, the ordered pair was 3, 4. And remember, we graphed it in quadrant 1 here. Then in quadrant 3, the signs on the ordered pair are going to be negative x and a negative y. And then the signs on the ordered pair in quadrant 4, positive x, negative y. Now again, notice all the triangles up here that have been created. Notice they always go back to the x-axis. So this would have been, for example, the ordered pair that I just did, 3, 4. You connect from 0, 0 to that ordered pair, and then to make the leg of the triangle, draw a segment down to the x-axis. If you're in quadrant 2, same thing. You'll graph the ordered pair. Let's say this was negative 3 and positive 4. You're still going to graph that, draw the segment to connect that ordered pair, and then draw this one down to the x-axis. Then same thing in quadrant 3, and as well as in quadrant 4. So these are all examples here. Now, one thing that will help you to remember that there's an acronym to help you to remember what signs should end up on your fractions. So here is my acronym. In quadrant 1, it's going to be the word all, because what's going to happen here is all 6 trig functions are going to be positive. And notice how I just did that one example. Notice all 6 fractions were positive. In quadrant 2, my next word is going to be students. The acronym is all students take calculus, And each one of the beginning letters in the acronym, we're using the whole word all there. But the S in students stands for sine and it's reciprocal. These are the only 2 out of the 6 that are going to be positive. The other 4 are going to be negative in quadrant 2. In quadrant 3, the T stands for tangent and cotangent. These are going to be the only 2 that are positive in this quadrant. Because if you think about it, remember the signs in this quadrant are negative, negative. And remember, for tangent, it's y over x. So if you do a negative number over a negative number, this is going to simplify to a positive. All the other ones, when 1 is negative, it's going to end up being a positive because r is going to be positive. And then for the calculus, this is for cosine and secant. These are going to be the only 2 that are positive here. The other 4 are going to be negative. So for example, sine, cosecant, tan, and cotangent, these 4 are going to be negative. These are the only 2 that are positive in quadrant 4, only 2 in quadrant 3 that are positive, and in quadrant 2, these 2, but in quadrant 1, all 6 are positive. This is going to help us to check our answers once we put them into the fractions. It's also going to help us later on when we're solving things. All right, so it says the terminal side of angle theta in standard position passes through the point 815. Find the 6 trig values of theta. So let me go ahead and graph it and give you a visual. We really don't need to graph it because remember, when you're given an order pair, the first number is x, the second number is y. R, remember, you're going to memorize this formula that it's r is equal to x squared plus y squared. So it's 8 squared plus 15 squared equals 64 plus 225. And you get 289, square root it, and your value of r is equal to 17. For those of you who remember your Pythagorean triples, this is a Pythagorean triple. So my x is 8, my y is 15, and my r is 17. Let me go ahead and graph the order pair and show you how it's creating angle theta and how you'll turn it into a triangle. So if I make my x and y axis here, really all I need to focus on is quadrant 1 because my order pair was positive, positive. So 1, 2, 3, 4, 5, 6, 7, 8, and then I need to go up 15. So my order pair, 8, 15, is way up here. I'm going to connect it from 0, 0, and this is actually the hypotenuse of my triangle. Remember, when you form the triangle, you're going back to the x-axis. And then here is your triangle. So remember, your x value was 8, your y value is 15, and you found the hypotenuse to be 17. So this is x, this is y, and this is your r. So this is the triangle because angle theta is right there. Now again, if you wanted to do SOHCAHTOA, technically you could if you're going to give yourself the visual. Because again, the 15, this is my opposite to theta, this is my adjacent, and this would be my hypotenuse. But I'm going to go ahead and just use the x, y, and r values. So now let's go ahead and find the values of the 6 trig functions. So remember, sine of theta, why should you send y over r? So we're going to do 15 over 17. Yes. All right, so the reciprocal to sine is cosecant. So all you have to do is flip it. It's now r over y, so then it's 17 over 15. Cosine of theta, this is the one since sine got y, cosine gets x over r. And then we'll fill it in. X is 8, r is 17. Reciprocal to cosine is secant. Flip it, r over x, 17 over 8. And then tangent, this one's y over x, so 15 over 8. its reciprocal is cotangent. Flip it, x over y, and then it's 8 over 15. So all you're doing is figuring out your r value. Your x and y will be given to you as an ordered pair, and then you just plug them into the 6 values, the functions. Let's do the next one. Notice the next one. The sign or the ordered pair is -3, -4. Yes. When the ordered pair is a negative, what quadrant is it in? Quadrant 3. Good. So if you want to give yourself the visual and graph it, you can. You don't have to, because I can find my r value just by taking my x and my y, squaring them, and that'll give me my r value. Remember, r is always positive. So here I would get 25, square root it, and my r value is 5. So x is -3, y is -4, r is 5. The triangle that would have been formed, if you want to go ahead and create it, I'm really focusing just on quadrant 3. So 1, 2, 3, 1, 2, 3, 4. So -3, -4 is right here. Create the terminal side of the angle. My initial side is here. So theta is located here, and it's always back to the x-axis. So again, this would be -3, -4, and +5. So now I'm just going to take my x, y, and r values and plug them in. So for sine, remember, why should you sin? Y over r. So that's going to be -4 over 5. Its reciprocal, cosecant. Correct. So 5 over -4. Cosine, x over r. -3 over 5. Reciprocal is secant. Flip the fraction. R over x. And then here, this one should have been r over y. I didn't write it in here. And then here, 5 over -3. Tangent, y over x. -4 over -3. Now, negative turns positive. Remember, in quadrant 3, all students take calculus. The only two that should be positive in quadrant 3, because of the word take, is tangent and cotangent. So this is how we're going to get a positive answer, by dividing a negative by a negative. So the only two that should be positive are the ones are going to be tangent and cotangent. So if you want to, on your paper, say the acronym in your head, all students take calculus. And remember, in quadrant 3, the T stands for tangent and cotangent, and those are the two that are positive. The other 4 should be a negative fraction. Now, on, like, for example, the sign where you had gotten -4 over 5, remember that when there's one negative sign, you can also pull it to the front of the fraction. Or if the negative sign was in the denominator, all 3 of these fractions mean the same thing. But when there's 2 negatives, you do need to simplify it to a positive. R happens to be a radical. You're going to need to rationalize if you end up with a square root in the denominator. So just remember that same rule that we've learned already. Okay, so these are when the ordered pairs are actually in the quadrants. Now we're going to do some examples where the ordered pairs are on the x and the y axis. And these are called the quadrant angles. So whenever we're dealing with, say, a 90-degree angle, or a 180-degree angle, or a 270, or a 360, or even the negative, if we went clockwise. When we draw these angles, we're going to be using these 4 ordered pairs. So for example, if they said to find sine of 90, the 90-degree angle, this would be my terminal side, this would be my initial, here's my 90-degree angle, and I'm using this ordered pair. I'm not making a triangle here. I'm just using the ordered pairs on the X and the Y axis. So if it was 180, you would use this ordered pair. 270 here, and then 360 would be this one. Now, if it asked you for a negative, you would be doing negative 90 would be here. Same ordered pair for the positive 270. Negative 180, same as positive 180. And then negative 270 would be up here. So let's go ahead and again, same thing. Sine is y over r. So sine of 90. Now, one other thing, whenever you're using these four order pairs, your r value is always going to be 1. Now, I'm going to show you an example with one of the order pairs. So let's do the sine, let's do the 90 degrees. So for 90 degrees, the order pair, 0, 1. So x is 0, y is 1. So to find the r value, same thing we just did, let's plug it in. And we would get 0 squared plus 1 squared, 0 plus 1. The square root of 1 is 1. So my r value is 1. You will get this same r value no matter which one of these four ordered pairs you use. The r is always equal to 1. And this is sort of leading us into our unit circle where our radius length or our r value of the unit circle is always going to be 1 because one unit is 1. So let's go ahead and now that we have our r value and our x and y value, so remember for 90 degrees, we're using the ordered pair 0, 1. So my x here is 0, my y is 1, and I'm using r equals 1. So now I'm just going to plug it in, and I'm going to do y should you sin, y over r, and then we get 1 over 1, which simplifies to 1. For its reciprocal, flip it, r over y, well 1 over 1 is still just 1. For cosine, you're memorizing it as x over r. This time my x is 0, my r is still 1. When the 0 is in the numerator, it simplifies to 0. However, when I flip it, the 0 moves to the denominator. And remember, when the 0 is in the denominator, this is undefined. So this is going to be no solution. So when you have a 0 in the bottom of the fraction, it's undefined, so it's no solution. Then if I do tangent, tangent is y over x, 1 over 0. This one is also undefined. But then if I flip it, x over y, the 0 is now in the numerator, and 0 divided by 1 is 0. So if I wanted to graph a 180-degree angle, my 180-degree angle would start here on this initial side, come around here, and stop. And the order pair it's going to use is going to be the -1, 0. So x equals -1, y equals 0. And again, your r value for any of these four order pairs will always be 1. You could do the calculation, but trust me, the r value is 1. So for sine of 180, sine is y over r. So y over r. And again, we're using a y value of 0, r value of 1. 0 in the numerator simplifies to 0. For cosecant, it's reciprocal. Flip it. R over y. And then this flips to 1 over 0. 0 in the denominator, no solution. Cosine, x over r. My x is -1, my r is +1. -1 divided by +1, -1. Flip it, r over x, 1 over -1, and it simplifies to -1. Tangent, y over x. My y value is 0. X is -1. 0 in the numerator is 0. Flip it, x over y. -1 over 0. No solution. It's undefined. All right, for this one, the reciprocal identities. So we've already seen this. The reciprocal to sine is cosecant, the reciprocal to cosine is secant, and the reciprocal to tangent is cotangent. So for example, if they asked me, or if they gave me that the sine of theta is equal to 4/5, and they said, find cosecant of theta, all you have to do is flip the fraction. So this is applying or using reciprocal identities. So memorize that the sine of theta is the reciprocal to cosecant of theta. Cosine, its reciprocal is secant. Tangent, its reciprocal is cotangent. So let's try 2 examples applying these reciprocal identities. Okay, so for this one, they're giving us secant. Remember, the reciprocal to secant is cosine. So if I want to find cosine of theta, all I do is flip the fraction, and it becomes 3/5. For the next one, they're giving us cosecant. We need to find sine. These are reciprocals. Now, what's different on this one? When I flip it, my radical goes to the bottom. I got to rationalize this.
So you got both sides by square root 6?
Correct. So then we would get -2 times the square root of 6 over 6. I can simplify my fraction. I can divide both of these by 2 and make this a 3 and a 1. So the final answer, -√6 over 3. So when your radical ends up in the bottom after you flip, you will need to rationalize. Okay, next one. So these are going to be some solution intervals. Now, in the homework, the way that you're going to use these solution intervals is they're going to give you a question and they're going to ask you, is this possible or impossible? Now, these solution intervals for the sine and the cosine, if you think back to your geometry days and you think about your triangle here, and let's say we have A, B, C, and remember, let's say I wanted you to find sine of angle B. So let's say I just put 3, 4, 5 here. So remember, the hypotenuse is always the biggest side. So if I wanted to find sine of B, I would be doing opposite over adjacent. Or even if I did cosine of B, this would have been, so this is O over H, and this would be A over H. Remember, the hypotenuse is always the biggest. So here, if I do 3/5 or 4/5, notice it's a fraction. It's never going to be an improper fraction because the denominator, the hypotenuse, is always the biggest. So this is why the interval here for sine and cosine, notice it's going to be a number between -1 and +1 because it has to be a fraction because the denominator is always going to be the biggest number. So for example, if I give you a question and I said sine of theta equals 2, and I'm going to say, is this possible or impossible? And if you know that sine always has to be a fraction, you're going to say that this is impossible. Sine and cosine always has to be a fraction. Now, if I said cosine of theta equals -1/2, it can be a negative fraction. This is possible. So it has to be a positive or a negative fraction. It can also be +1 or -1 because notice the symbol. It's less than or equal to. So it's got to be a number in between -1 and +1 for cosine and sine. Now, yes, we're going to use the solution intervals. So the reciprocals here. So if sine and cosine are fractions, then secant and cosecant are going to be improper fractions or whole numbers or integers. So for example, if I said, is the secant of theta, is secant theta equal to 2 possible? Yes, right? It can be a whole number. So this is possible. But if I said cosecant equal a half, this would be impossible. The reciprocals cannot be regular fractions. They have to be improper or integers. Now, if you think back up here to my triangle, remember tangent, if you remember back in geometry, it was opposite over adjacent, and cotangent would have been the reciprocal. So opposite would have been 3/4, but reciprocal would have been 4/3. This is why tangent and cotangent are all real numbers. And notice they have the symbol here from negative infinity to positive infinity. So tangent and cotangent could be anything. So when you're doing the homework, you're going to get questions and they're going to say, is this possible or impossible? Now, what's going to be coming up also is the Pythagorean identities. You're going to need to memorize these. You're also going to need to be able to manipulate these. And what I mean by that is, let's take the first one. It's sine squared theta plus cosine squared theta equals 1. So what we're going to be doing is using all of these identities, the reciprocal identities, the Pythagorean, the quotient, and we're going to be substituting in so we can solve things and simplify and verify. So one-on-one or individually, this is going to be easy, but once we put it all together, that's where it gets challenging. So what I mean to be able to manipulate this, I mean be able to solve this Pythagorean identity for, say, sine squared theta. So what I would mean would be to subtract cosine squared theta and then isolate the sine squared theta. So be able to figure out what sine squared theta equals. It equals 1 minus cosine squared theta. Or vice versa, solve for cosine. So again, take the original and be able to isolate the cosine squared theta by subtracting sine squared theta. So be able to manipulate these different Pythagorean identities. Now, generally what we end up doing is we don't give you all the manipulated forms. We would maybe give you these 3, and you would have to be able to rearrange them on your own. But again, we're just using our algebra skills of either adding the same thing to the same side or subtracting depending on what's given. But you would need to memorize these. For an SAT, you would need to memorize these. This is not one of the formulas that they give you. Then the quotient identities, tangent of theta is equivalent to sine of theta divided by cosine theta. And then cotangent is cosine of theta divided by sine of theta. Always remember to include the angle. Sometimes they'll use an X here, but most of the time when we refer to the angle, we're going to use the symbol theta. So always remember to include that. All right, so here it says to use, now, technically on this one, I could figure out what my X and Y value is, but on the quiz next week, if the instructions say to use Pythagorean identities and you decide, you know what? I know that tangent of theta is equal to y over x, and if it's 4/3, I could say x is equal to 3, y is equal to 4, and then I can find my r value by doing this. If you do this on the quiz, when the instructions say to use Pythagorean identities, you're going to get it wrong, because you're going to have to show the work of how you apply a Pythagorean identity. You can do this to check your answer. However, you need to show me how you can do Pythagorean identities, and I'm going to show you what I mean by that. So it says it wants us to find sine of theta and cosine of theta, given that tangent of theta is equal to 4/3, and it's in quadrant 3. So let's take a look here. So in quadrant 3, here's 1, 2, 3. I know the signs on my order pair or my x and y value need to be negative, negative. So really what went in here was a -3 and a -4. So here's where I know that the only ones that are positive in quadrant 3 are tangent and cotangent. The other 4 are going to be negative. So this is a clue that once I finish my problem, the answers for sine and cosine need to be a negative fraction. If they're not, you've done something wrong. So here's how we're going to use the Pythagorean identity. So you're going to figure out which one of the three is going to enable us to use tangent. And the one of the three that has tangent in it is going to be tangent squared theta plus 1 equals secant squared theta. I need to substitute in what tangent of theta equals. Tangent of theta equals 4/3. But if you notice, the formula is tangent squared. So I need to square the 4/3. And then I still have the plus 1. And this is going to give me secant squared theta. So now what I need to do, and let me come on over here, I'm going to square the 4/3. This is going to give me 16/3 plus 1 equals secant squared theta. I need to add these fractions. So actually this should be a 9 because I squared the 3. I need to change the 1 so it has a common denominator. I'm going to change the whole number 1 and I'm going to make it 9/9. And this gives me secant squared theta. So now I'm going to add these, 25/9. Now, remember the reciprocal to secant is going to be cosine. But I'm going to square root it. And this is going to give me plus and minus 5/3 is equal to secant of theta. Now, here's where my all students take calculus comes into play. So if I do all students take calculus, and I'm supposed to be in quadrant 3, the only thing I'm going to keep, because in quadrant 3, only tangent and cotangent are the positive ones. So secant in quadrant 3 is negative. So I'm only keeping the negative 5/3 for secant. And now to find cosine, which is its reciprocal, I flip it, and it's 3/5. So this is my first answer I was looking for. Now I have to use a second Pythagorean identity to find sine. So for the next one, now we have to find sine. So the Pythagorean identity I'm going to use to find sine is going to be sine squared theta plus cosine squared theta equals 1.
Wait, but how do we know if it's...
So now I'm going to replace cosine squared with the negative 3/5. I have to square it. And now equals 1. So I'm going to square it. I'm also going to change the whole number 1 so it has a common denominator. So this gives me 9/25. So since my denominator is 25, I'm going to change my whole number 1 to 25/25. Subtract 9/25. And I get sine squared theta is equal to 16/25. I don't want square, so I square root it. And again, sine squared, or sine theta, plus and minus 4/5. But again, I'm in quadrant 3, so I only want the negative. And there is my other answer.